Okay, so the sports that we are going to be addressing with our invention are basically all of them, but specifically motorsports, such as MotoGP, F1, as well as rally sports, where you have to be quick, not only with your decision making, but also with reacting to things like the lights, the checkered flag, to ensure that you have an advantage over your opponents. We'll also be looking at things like tennis and paddle, which have balls flying at you at over 100 miles an hour. And you have to be very quick to react, deciding where to put it and how, how hard you need to hit it. So the problem that we were addressing is the reaction times of athletes were too slow. They aren't fast enough to react to what the opponents are doing. They aren't fast enough to react to what they have to do. So what we did, we made a portable system that allowed them to practice and their reaction time anywhere they go. This is why the design is like this, due to portability. It's around 30 inches wide. It drops down to 15. This way you can carry around with you anywhere.
Less than 15.
Less than 15.
Okay, so we had a lot of constraints with our materials because we basically used a lot of recycled materials, and so we basically had to do this one try, which made a lot of issues, and we were still able to prototype, just not as much as we'd hoped. So the first thing we used was some wood, and this picture right here is from my project last semester, but we used all our wood for this semester, and I did recycle it in Filix, so this is what you're going to get for now. But the wood was mainly for the frame, and it was around $20 for 4 pieces, 25-ish. It's been a minute, but yeah, and we used we used 2 pieces this semester of the 1/8 inch board from the bookstore, and that was for the frame. And then we also used a Pico kit, which was free because we just checked it out, and we're gonna have to return it on Friday. But within the Pico kit, we used the Raspberry Pi, breadboard, and the male-female wires, and the LED strip. And you can see in this that there is a piece of tape in the middle, and that piece of tape was given to us actually by somebody else, so we didn't have to spend anything for that, but it was really useful when taping down the wires and putting together our project. So that was also we didn't need to spend anything for that. The last thing that was also in the Pico kit was, well, it wasn't in the Pico kit, but I kept it in the Pico kit to hold on to it, was the button. And these buttons, painted over them for the colors, but yeah, this was just for the actual pressing of everything, and that was pretty much all of our materials. Very cost efficient. We used foam, of course, but that foam was again recycled from the bins in Filix. And yeah, that was the extent of all of our materials.
What is this? What is this? You want to
He's
scrap,
the next
huh?
David Dobrik, bro.
You want to scrap?
He's the David Dobrik of Northeastern.
I wish, man.
Oh yeah, I saw that.
Yo.
That shit does not exist, bro. What are we on about?
We are locked in. Cody did some
in.
crazy code.
The code.
Taking a little break.
Yeah, I mean, what do you need me to say about it?
I mean, we're good.
We're good.
We got the circuit right.
I brought some exterior outside help.
Very nice.
Yeah, done.
No doors. No problem.
You got a hinge?
It's a pretty jank hinge, I'm not gonna lie. Here, we take tape on. I'll explain the hinge.
Yo, we got a hinge.
You want lazy cut because these are 2 sports that like can take reaction time. Okay, damn, chill. Okay, as you can see, the hinge is basically floating, and you know why that is? Because we ran into a little issue that we had to solve. Hot glue doesn't stick on steel inherently, and if it does, it peels off. So we hot glued Velcro to the bracket.
Basically, the reason we used... he said, oh, the hot glue isn't sticking to the stainless steel. Let me use Velcro. Okay, so what do? I hot glue the Velcro to the wood,
Don't speak it first. Don't speak.
and then I Velcro the hot glue. I hot glue the Velcro to the wood, like this, and then what do I do?
I'll film you.
And then what do? I hot glue stainless steel to the Velcro.
In my defense, it worked for a solid couple days. And
No, it worked until I said, "Let me take it off."
the thing is,
It did.
This-
The point of Velcro is partially that you can take it off, and then we took the hinge off.
You're better off just super gluing it. Super glue sticks. to
they didn't
stainless
have
steel.
super glue. This thing, the first time I hot glued it, it fell off overnight. When I put it onto the Velcro, it's
switch
been
the
last.
wires.
I had to physically peel it off. The Velcro is supposed to be the Velcro is supposed to help it stick.
But like, anyways, but like, you know, should be working.
Okay,
here we
so
go.
this is the yellow button. Green.
Button.
Pretend to like click the wrong button real quick.
Oh, red.
If you
Is this
if you
red?
just press the wrong button, it doesn't work.
And so it takes more time. Yeah, you still
I like
got.
that. I like that.
You
still gotta color in the
One,
buttons.
you're just going slower.
Yeah,
I mean, like, from the start, there was a pretty clear vision of what this was going to be, though, right? Board with buttons on.
pretty much. What do you think this is?
I think it's a reaction board to test your reaction
wrong.
to the buttons. It'll like show you the buttons. You have to hit them after it shows you them. I think the foam is cut very well. I don't know how you guys got these such clean angles in it.
Oh, we got.
Nice.
I think Amazon did that.
Really. You guys did that.
All right. Good. Did you glue this side down, right?
Not yet.
No, the other side.
Yeah.
All right.
Push that down.
It's very tedious work. Has to be aligned right. Got the little wire right here to actually
Let's just keep
turn
it
it
down
on.
so it.
I'm thinking adding like a skinny.
You push these sides down, and I'll push the glue's here. Here and here.
Okay. Basically, we're gluing it down. Yeah. So we got Elliot here. He's gonna talk about the design.
Okay, so for the design of this project, first of all, you look at it like this. You're like, why is it half and half? One thing that's important when traveling for athletes is portability. And bringing something like this that can fold is extremely useful. Going from stadium to stadium, going from competition to competition is something that athletes need and that they're gonna love. Now the back is where the design really shines. Even though it won't be seen much, this is something that really stands out to show that this
It's better
isn't
than being
only-
plain.
Yeah, this isn't only a technical product, but also a decorative product. So usually components are inside when things are folding, but for this, we decided to have it outside since when you're stretching it that way, the wiring could get stretched and therefore pulling it
buttons.
out of the breadboard, the buttons would move, something would disconnect, so we didn't want to risk it. So we just folded it. When you're doing a reaction time tester, you're not thinking about what you're pressing, you're just pressing, and you're pressing as fast as you can. Pressing fast means pressing hard. So someone like an athlete could break their fingers or their hands, which is something that's very important to them, if this was a hard surface. This is a light surface. It doesn't matter if you hit it, if you misclick, your finger slips, you'll be fine.
It's also really lightweight.
Yeah, it does make it lightweight.
But it's a little hard to tell what the circuit looks like because it's well hidden. But yeah, we got our circuit in there. This wires connect to the buttons right here as well, and LED strip up here as well. But yeah, I mean, we got the handle. It's a pretty cool design. The wood reinforces it, but it's not too much. It's just enough. So yeah, that's the design. So got Cody here. He's gonna test it out real quick to show you guys how it works. So I'm gonna go. Yeah. This basically ends up in this file right here. This one. So we're gonna download this. As you can see, it's right here. I'm just gonna move this to the same folder that has the MATLAB path. And then we go to MATLAB, and then this is our code for the MATLAB thing. And if we run it, it's gonna give me some statistics right here. It's also gonna output a graph showing how fast I clicked each button. And it's gonna track it as the practice number, and it's gonna give the date of the practice too.
Okay.
Let me move this back a little bit.
One of the most difficult parts of the project that we've seen is how new everything is. We're all making it from scrap, really. I mean, of course, there's some things from the internet that can help us. Like, thank God for like some of the GitHub from Filec, the SharePoint, and what Cody used for coding. Soham did the design all from scratch, and the wiring took a lot of work to make sure that all of them work in unison. And I think that was one of the most difficult parts, just making everything from what we know.
It's it's a little bit tricky to get everything done in parallel because the wiring has to fit into the frame and the code has to work in the wiring.
Doing it all in parallel was also one of the most difficult things.
I mean, a lot of this project was collaboration, which was a struggle, not just because it was like a collaborative thing, but also just, as I said, meeting together and everything. Like, it's not that we didn't want to, it's just the fact that so much of this project required all these components kind of working in unison. The wiring was necessary to build the actual project because it was kind of centric around how all the circuit parts would be in the project. The wiring was also reliant on the code to make sure that like the buttons functioned and worked with the code as well, and just to see how everything functioned, especially because half the time we were sick.
Not to mention the whatever the hell's going on with our actual methods of communication. Sometimes it just didn't work.
Someone has a Samsung, so iMessages aren't the...
Yeah, I think Ellie wasn't getting my text through the group
I get
chat.
I get only private texts.
Yeah, which
Group
was
chat
so
texts
weird.
are-
My phone broke halfway through the project, and I had to get that replaced. Like, I nearly lost like my ability to communicate with everybody here and at home. So there's so many random things we just could not predict with communication. But I mean, these kinds of extraneous factors are to be expected, and we pulled through. All right, I'm back. So at this point, we have the project done, and it's only a matter of testing it, you know, getting it out there, letting people try it. And so we tried it on our own a little bit, got our times down, got our practice in, so on and so forth. But we weren't satisfied. So we did what any sane human would do. We went to Spear and let a bunch of people try it out. So here's a little montage of that.
Today why is it on again? What's up, guys? Today we're gonna Habibi. Okay. Gotta stay agile. You know which color it's gonna be? Purple. Bang.
Yo, so I was just wondering.
Purple. Twice in a row. It's like confusing me. Green. Yellow. Yellow. I'm colorblind. I gotta take my jacket off.
Make it go faster. Blue, white.
That's green.
Why are the blues and whites getting confused, bro?
Only $9.99 on Amazon.com. Shipping not included. I want to see if Amazon Prime. Red. Bang. We're still going though. Blue.
I won.
Oh, the gym?
The random value is 4.6, so that you don't really know what's gonna happen. How long you're gonna wait until the next click.
I really don't. Wait, what's happening?
Wait, I think the game's over.
No, it would turn off.
I think you.
I mean, we clearly can't just eliminate the problem of reaction time since it's humans that are going to be playing these sports.
We can limit this.
But we can just limit it to how bad it is by practice. Practice makes perfect. With quick hands, it will become perfect.
Hey, big bro, how many pictures you trying to take, bro?